In this video, I'll be covering enumerations. Basically, enumerations, what they do is they define a common type for a group of related values, and they allow you to work with these values in a type-safe manner within your code. One awesome thing about them is they don't need to be assigned a value for each case. And if a value is assigned or provided for the case, it can be a string, character, integer, or a floating point type like a double. Alright, so my first example here is a compass. A compass, of course, has 4 directions, and in this case I give it 4, north, south, east, and west. And this is the basic syntax of an enum. So you begin an enum with the enum keyword, you give it a name, and I kind of kept my notes here about naming enums, but basically when you define an enum, the name needs to start with a capital letter, and it needs to be singular, not plural. So in this case, compass, of course, compass is a compass, but in some cases, for example, I'm going to do one involving the planets. And so instead of saying enum planets, I'll do enum planet because I'll be defining the planets. Okay, so let me go ahead and show you the planet enum that I created. So we do enum, enum. I can type here without hitting the cap lock. Alright, so enum, and like I mentioned, I said planet, right? And we do our curly brackets, and I define the case. So if you notice, I didn't do planets, I did one planet. Another thing that I also wanted to show you is that you don't necessarily have to list each case like this. In a row, you can actually list your cases in one single line. And so in this case, I'm going to do one single line: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And if you noticed, when I did the line, listing all the cases in one line, I used commas in between each. Okay. So another thing I wanted to show you with enums is type inference. So say you have a variable. Let's do direction. Swift is really great about type inference even when it comes to enum. So I can set this equal to compass dot east, and if we hover over by holding down the option key and hovering over direction, we can see that direction is of type compass, and compass is our enum from above here. So Swift is smart enough to realize when you actually do use an enum as its value that obviously the variable or the constant that you assign it to is going to become that type. Okay? Another thing you can do is you can reassign direction to another case, but without all this typing. So I'm going to actually reassign direction to north. So I'm going to do dot north. And it's smart enough to realize, okay, well, direction is of type compass, therefore if you do dot notation without adding compass in front of it, that it is the same type. Again, if we hold down the option key and hover over direction down here, we'll see that sure enough it's still compass, of type compass, that we defined up here. Alright, now it's all fine and dandy, but what can we do with this? Well, we can match enum values using switch. So again, keeping with the direction, let's go ahead and create a switch that we can have it respond to the type. So we do direction switch, and we're going to call the variable that we're going to switch on, which is direction. We do our brackets, and then we do our cases. So in this case, we want it to be switch statement to be exhaustive. So we want the switch statement to list all the cases up here. So let's go ahead and create a case for each of those. Our switch statement case, we do dot north. I'm going to have it read, actually let's go ahead and print out. Heard it was cold there. Right. Okay, my other case, do south, print. Let's do heard the penguins were nice. We'll do our next case, west, print, onward to sunset, and then we'll do case east, which is our last case. So we're making our case or switch statement exhaustive because we have a result for each and every one. And if we didn't, what do we use? Default. So, okay, do onward to sunrise. Okay. So as you see, the switch statement has already evaluated and printed out heard it was cold up there because we set direction to north. So it already went through and output what we needed to. Okay, continuing on, the next thing I want to cover is associated values. So basically associated values, they allow you to attach data to instances of an enum, and different cases, different cases can actually have different types of associated values. It's useful to store associated values alongside your case value because it permits the information to vary each time you use the case in your code. And I'll show you an example of that. So my example is actually going to be an enum that evaluates different shapes and allows you to output the area and perimeter of said shapes. So let's go ahead and create one. So enum, do shape dimension. Again, I didn't say dimensions because remember it has to be singular, not plural. I made sure that my enum name is capitalized. Okay, so I'm going to define 4 shapes. My first one's going to be a point. I kind of wanted to keep something a little bit simple, like my examples up here, where we just have one case and no associated values with it. Because a point, you can't define the area or its perimeter, so it's nice to see a different example of it. Okay, so my next one is going to be square. Now square we know has sides of equal length. So all I'm going to do is define what its one value will contain. And it's going to be a double. Alright, so my next one is going to be rectangle. Okay, so rectangle we know in order to determine its perimeter as well as its area, we need 2 values, the width and the height, because they're different. So here I'm going to actually create a tuple. I'm going to do width, name it, and its type is a double, and then height. Its type is also going to be double. And the next shape I'm going to do, next and final shape, is a triangle. Now we all know that triangles, I just want to do a right triangle because I really don't want to do the math right now. And it's actually trying to do the formula for a right triangle was pretty nasty all by itself. So you'll see what I mean. And again, right triangle, all we need is the width and the height. And do double, and then height, also a double. Okay, so you see here we have square, rectangle, right triangle. Now, as we know, if we put different things in here, the value can vary every time we put something in there, because we could, you know, figure out what the square is, you know, of different sizes. Okay. All right. So the next thing we're going to do is actually create a function to, you know, calculate what the area and height is, or the area and perimeter is for our shapes. Now, one thing I wanted to mention, I was going to do a video on this, but I'm not going to, because methods are actually really easy. So basically, what determines a method is one, it's a function. So methods equal function, okay? The thing to remember is where they are located in the code. So basically, a function becomes a method when it is in an enum, a structure, or class. So if they occur within these curly brackets, said curly brackets, the function that you define will become a method. That's it. That's all you need to know. I mean, there's more to know, but I'm not going to go into huge detail. If I do run across something that, you know, is important, I'll bring it up. But basically, I'm going to create methods within this enum so that this enum can do work. So again, it's a function, but because it's located in these curly brackets, it will become a method. Okay, so my first one I'm going to do is area. Okay, so it's not going to take any parameters, but we do need to return a value, which would be double. Okay, so how do we incorporate enums? Well, if you remember above where I did a switch statement, that's exactly what we're going to do inside this function. We're going to actually do a switch statement. The thing is, I'm not going to define a variable up here. I'm going to say on self, so that it knows, okay, I'm inside a function and it contains cases, so look inside yourself, up here within yourself, and do the math, or do the switch. Okay, so I'm going to first define case, so again, point. If you notice I didn't do shape dimension dot point, I just did point. Okay, and since we can't determine the area of a point, we're just going to return 0. Okay, our next case is a square. Okay, so if you notice, it highlighted double, so we need to put something in there. So we'll just do side. So that's exactly what it's going to be. It's going to be one side, but all the sides are the same. To do that, now we're going to return side times side. Okay. Oh, I forgot, and I'm throwing an error message. Unresolved identifier side. So what I forgot to do was actually make square a constant. Okay, now I shouldn't have any issue. Okay, I do have an issue, so the switch must be exhaustive, which I'm working on. Okay, so case, again, what, dot, now we do rectangle. If I can spell. All right, now that we have rectangle, don't know why this is. Okay. In this case, what we need to do is we need to return the tuple. So width is W, and then height is going to be H. I've got my colon, return, and let's see here. Don't know why I'm getting so many errors. Okay, I'm just going to type away. So how do we determine this? We do W times height, or width times height. Then our last one is right triangle. So do dot right triangle. Again, let's do width, height again. Return. Now we have to do some math here, so I'm going to do some encapsulating so that you don't get the wrong issue. So the area of a right triangle is the width times the height divided by 2. Okay, and I've got a colon here. All right, no error messages. Yes, okay. The little things. All right, so I'm going to go ahead and show you kind of see if our area method even works. So let's do var square equals, do shape dimensions, so we're calling this enum. I'm going to call square, I'm going to give square, let's do 7, the length of 7, okay? And now let's have it do some work. So I'm going to print square, and now how do we call it area? Well, we do dot notation area, and there you go, 49. So our math obviously works, because yeah, 7 times 7 is 49. Okay, so we got our method to work. Now you're saying, well, how did you make that method work? Well, the thing is, because the function here, the method, is defined inside the enum, we can actually call area once we've assigned this variable a type. And in this case, again, if you hold down the option key, hover over square, click it, we see that square is of type shape dimensions, which is an enum, and so square inherits everything that's inside enum. Methods, everything. So basically, since we've made this an enum, then we can just call square, we can call area on square. So there you go. Alright, so let's create one more method. This time I'm going to do perimeter. So func again. I'm going to do perimeter. Again, this is not going to take any parameters, but it does need to return a value. Curly brackets. And again, we're going to do switch on itself. Curly brackets. And let's define our cases. So again, do case dot points. No, does not have anything. So we're just going to return 0 again. Do another case. Square, and we just do side, like we did before, colon, and return, which is side times 4, because we have to count all the sides. Oops, we've got this little space in there. Okay, next is our rectangle. And again, as you see, it was pretty smart. I just, it's in there, so we're just going to do W. Oh gosh. And then H. Okay. Alright. Have a colon. Colon. And then return. And now do some, again, some encapsulation. Order of operations, that's the word I'm looking for, not encapsulation. I guess you could kind of consider that, but it's not. Okay, H times 2, because, a rectangle, we have two sides. Okay, I'm not sure why that error is appearing. Maybe it might resolve itself when I'm done defining triangle. So right triangle, W, and H again, colon, return. Now here it gets kind of wonky, so bear with me. I'm actually going to do the square root. So SQRT, and because I have to take the square root of height squared plus width squared, I'm actually going to use some more parentheses here, and plus more parentheses, and close the parentheses. And then I'm going to do width times width, then height times height. Okay. Make sure I had all my parentheses in there. And then what we do is we do plus width plus height. Alright, so I have a bunch of errors. Let's see what I did wrong here. Square side, switch parameter self. Just do S, see what happens. Still do not like it. Okay, I'm not really sure why this is happening. So I was able to get it to work before, so I'm actually going to copy and paste my previous code in there. I do like to try to figure it out, but I don't want to make this video too long. Okay, there you go. Oh, that's what I forgot to do. Okay, can anyone guess what I forgot to do? Oh, I forgot to do let. Make these constants. Right? Right. That was my problem. Okay. And now all the errors should go away. And they do. Yay! Bye errors. Okay. So, let's play around with our new method, perimeter. So since we already have the square here already defined, let's just do print square, oops, not square root, square dot perimeter. If you noticed, I don't know if you noticed that, but as soon as I did the dot notation, it automatically Swift, already realizes, hey, this enum has two, or this particular value or variable has two methods available to it, and it's perimeter and area. So that is pretty nifty that it recognizes the type and what its methods are. Okay, so we get 28. That's absolutely correct. And I just want to really quickly check my triangle one. So triangle equals shape dimension. And triangle, oh, right triangle. And again, you see our little tuple here. So let's go ahead and give it a width of, I don't know, let's do 10 and a height of 5. Why not? All right, and you see here, right triangle has its two associated values. Okay, now let's go ahead and print out triangle and its perimeter. See, 26.8, I actually did the math, that is actually correct. All right, and print triangle dot area. Okay, and there's our area, 25. All right, so there we go. All right, moving on. So the next thing I wanted to cover is raw values. So basically raw values and explicitly assigned raw values, as well as accessing them. So raw values, what are they? Well, you can actually, instead of, before I was talking about associated values where you associate the values, we can actually give our enum cases actual values, like default values or raw values. Now the thing to remember is they all have to be the same type. They must be unique within the enum declaration, so we can't, have duplicate whatever. They have to be really unique. They can be strings, characters, integers, or float point types, like double or float. All right, so let's give you a really quick example. So enum, let's do ASCII control characters. So we'll do ASCII control char, and these are going to be characters. These will be type characters. If you notice, I'm giving the enum a type, saying everything in this enum is of type character. And then we do our cases. So we're going to do case tab, case line feed, case carriage return. I was going to do just return, but it's a reserved keyword, so you can't use it in Swift. Reserved meaning it will throw a flippant error. So, and if I just did return, you see how it turned pink because it's reserved. So I can do something like C return, and now it shouldn't have a problem. And it doesn't. Okay, so we got an error, wonderful error message. Now, this is saying enum cases require explicit raw values when the raw type is not integer or string, literal, convertible. So, because I've given this enum the type of character, it's saying, okay, hey, this is not string, this is not integer, so you need to give me some values. So let's go ahead and give this some values. So in this case, I'm going to give tab /t, and it should be fine. And again, you see the error jump down to the next one, line feed, because we need to do the same thing. So let's go ahead and do line feed, which is \n, and then return just \r. Okay, so there you go. That's how you add default values or raw values. Now, thing is I did explicit. These are explicit, explicitly defined default raw values. Okay. You can also do implicitly assigned raw values, which basically means that you don't have to explicitly assign a raw value for each case, and that Swift is actually smart enough to understand what you are inferring. When you set at least one, you have to set at least one value, one default value to a case. So let's go back to my planet list. And because I'm actually going to copy this over, actually no, I'm going to just go up here. I think I defined all the planets up here. I did. I'm going to copy this. I'm going to change the name because, one, I don't want Swift to freak out, which it will. Watch if I paste it here. It's going to freak out, yeah, because it was already declared above. So I'm going to do planet order. And why am I doing planet order? Well, I'm actually going to give all of these cases an order. So, and how do I implicitly imply the order? Well, I have to set at least 1 to a raw value. In this case, I'm going to set it to 1. And I also have to, of course, give it a type. In this case, it's going to be int. Okay, and the error goes away. So basically what I've done is I've given Mercury a value of 1, which means what Swift is going to infer is that Venus is going to have the value of 2, Earth is going to have 3, Mars is going to have 4, etc. So how do I know that? Well, I can actually access the raw value. And I was going to show this after I showed default, but I think I'm just going to show it now. So accessing raw value to prove that Swift has actually assigned raw values to all these other cases. So how do I access raw values? Well, first I'm going to assign it to a constant because I just feel like it. And I'm going to do Earth. I don't want to say Earth. Okay. Planet order. I'm just going to say Earth. Why not? Equal to, and I'm going to have this equal to planet order. Now I do dot syntax here. I'm going to do Earth. And as you see, we have hash value and raw value. I want raw value, and what this is going to do is it's going to pull the value out. So you see, we have 3 as our output, which means that it did actually infer what all of these cases values were based off of our first one that we assigned, which was to Mercury. Okay? Now, if strings are, and I just want to point this out, if strings are used when you define an enum, then all the cases will actually use the case name as its raw value. So again, using the compass example from above, do enum, I'll just say compass new, can't think of anything right now. And we do case north, south, east, west. But if we set the type for compass new as a string, it will infer, actually it will assign the case north to its actual name as the raw value. And I'll show you what I mean. So let direction new equal compass new dot, now we're going to assign a raw value, right? North, raw value. As you see here, north has become direction's new value. So, north's raw value, the case north, its raw value is its name, because we've said, hey, this enum up here is of type string. So therefore it defaults to say, okay, well, if that's the case, then it means that the case name is the raw value as well. Okay, and I've already showed you how to access raw values. So you just do compass north, raw value. All right, so onward we go. I didn't mean to type that in there. All right, so the next thing to cover is initializing from a raw value. What does that mean? Well, if we are defining an enum with raw value type, an enum will automatically receive an initializer that takes the value of the raw value types as a parameter. And it returns either an enumeration or nil. And the thing is we can use this initializer to try to create a new instance of the enum. What do I mean? Well, let's go ahead and give you an example. So how do we like ID or find Uranus from its raw value of 7? So, and say we don't know it exists in the enum. Well, we can say, well, let possible planet equal planet or order. And then what we do is, okay, well, for planet order, we want, again, to convert from value of raw value yielding nil if raw value does not respond to value of self. So basically we're saying, okay, well, hopefully that this planet order enum will contain the value 7. So if you notice, we have the question mark here. If we look it up, we can say raw type can be used to represent all values of self. So we get a lot of different info regarding instance properties and initializers and whatnot. Again, like if you have any question about anything with Swift, just click around because you'll get the answer. Anyway, so what I want is definitely raw value, and I'm going to say, hey, if there is something at value 7, which it is, assign it to possible planet. And here we see Uranus has been assigned to possible planet. But sometimes not every value, raw value that you put into this will actually contain something. In this case, it's a failable initializer. And how do we avoid like getting a null back? Well, we use optional binding to test to see if, hey, there's a match, assign it. If not, don't. So let's go ahead and do optional binding. So let's create a constant. We say, hey, is there planet position actually, we say planet position to find, and we're going to say 11. Now, we know there's not 11 planets in our solar system, but for sake of argument, let's see if we were an alien we didn't know. If there was 11 planets in the solar system we're visiting, we were studying it, we'll say, hey, is there a planet here? Sorry, I'm having a Star Trek type of throwback here, but so if let is our optional binding equals, we do planet order, and then we do a raw value, and we do position planet position to find, and then if it's successful, we'll do a switch statement, say some planet case dot earth. We want to say, okay, if it's earth, return. Actually, no, we want to do print safe for carbon life forms that breathe oxygen. And then we'll just do a default because I'm not going to go through each case. Print not safe. I'm going to just copy all this here because I don't feel like typing. Okay, now if it's not successful, if this if statement fails, we need to say, okay, well then we need to output print there is not a planet at position, and let's do some string interpolation, planet position to find. Okay, So as we see here, there's not a planet at position 11. That's correct. There's not. Let's say we do Earth, and we see safe for carbon-based. Gotta get it right. Life forms that breathe oxygen. And then we say default, not safe. So if we did like 6, it's not safe. So that's initializing from a raw value. So the next thing I want to cover is recursive enumerations. Oops. Okay. So let's type this in, recursive enumerations. Now what are recursive enumerations? Well, it's basically an enum that has another instance of the same enum as an associated value for one or more of its enum cases. I know that sounds really confusing, but basically it's an enum that references itself. Yeah, the best way to do this is just to jump in with an example, because I mean, it took me a while to wrap my mind around recursive enumerations. So, and I found examples helped out a lot. So, a great example, let's keep with the kind of the math stuff. I'm actually going to do or create an enum that takes a math expression that that has like order of operations, like I did before with is it triangle, where you see I had to do order of operations here. So we're going to actually create an enum that will do this type of work for us in a way. Okay, so meaning that we can input things that belong in parentheses, have that calculate, and then tack on whatever's left and have that calculate after we've done the calculations inside the parentheses. All right. So how do we do this? Well, let's go ahead and create an enum. I'm just going to do math expression. I'm going to do curly brackets. Now, what I'm going to do is I'm going to do case, because I want this first to take in a number, because we know we have to add different numbers. So I'm going to do number, and we're just going to do integers right now, just to make it easy. But now we want to do different math expressions, or operations. So addition, subtraction, multiplication, division. So let's go ahead and add those. We're going to do case add. Now, case add, what do we need? We need to take in either a number, it might be a number, or it might be an expression. So it might be, just 2, or it might be 2 plus 5. So how do we account for that? Well, what we do is, to make it recursive, this particular case recursive, we need to actually add indirect. Now what indirect does, its keyword, is basically the compiler has to insert a layer of indirection when it works with recursive enums, so you have to use the keyword indirect before the case, or if your whole entire enum will need this type of indirection, then you can just put indirect in front of enum here, like so. So every case that appears inside this enum will be indirect. So you can do either way. I'm actually just going to keep that there because it's nice, but say if you only have one case, or 2 cases, that only needed to have indirection, then you can just attach it to the case. But in this case, or in this example, I should say, I need the indirection for pretty much all the cases. Don't necessarily need it for number, but yeah, it doesn't hurt. I mean, it's not going to hurt it in any way if I have it as indirect. Alright, so what I want this to do is I want this add enum to accept either 1, a number, or 2, another math expression. So what I need to do is say, okay, well, math expression. So what this is saying is that add has access to anything that's in here. So it's actually referencing itself. Does that make sense? It just kind of references itself. And do the same thing for subtract. Do math expression, because it could be an expression, it could be just a number, we don't know. We want to give it that flexibility. So case multiply, math expression, case divide, math expression. Okay, there we go. We have our indirect enum for recursive enumerations. All right, so let's have fun with this. All right, so I'm going to create a function, not a method, because remember methods, if it's inside the enum, it's different. And I kind of wanted to show you that you can do functions outside of an enum. And so you have an example of having the function become a method inside an enum, or just having a function outside the enum that's just a named function. Okay, all right. So this function is going to evaluate what it will evaluate the expressions, basically. So it's going to take in one parameter, and that's going to be math expression. So it's going to take in an enum, and it's going to output an integer. So we want this function to give us the answer. Okay. All right, we got a nice little error. It's asking about return. We'll get to that. Okay, so remember before when we worked with enumerations, how do we, get through them? Well, we use switch. So we do switch on the expression that comes in curly brackets. And then we have to add our cases for each expression. So we have 5 cases: number, add, subtract, multiply, and divide. So we do the first one, which is case number. And we just give it a let value. So we're saying, okay, whatever comes in is going to be a constant value. And return said value. Because there's no math involved with a number, it's just a number. The next one we're going to do is add. We're going to do the numbers on the left and right. So we do let left, let right, and return left plus right. So it's math, right? It's addition. And then case subtract. Again, just do left and right again. Why not? Colon, return left minus right. The next case is multiplication. Let left, let right, colon, return left times right. Actually, subtraction should be right minus left. Either way, you can do it either way, but I think it's this flip-flopped math, if I recall. And most people, when they put in numbers, that's what they think automatically anyway. So at least I do. I don't know about anybody else. Return, flip-flop it, right, divide by left. I could be wrong. No, it's always could be wrong about certain stuff. All right, so we got error messages. Okay, yes, I did forget a colon there. Does that fix everything? Nope, it doesn't. Oh, I know what I forgot to do. So, it's saying that a binary operator cannot be applied to a math expression operands. So it's basically saying, okay, yeah, it's an operand, but we can't do math on that. Totally understandable. So, what do I do? Well, what I can do is actually evaluate the evaluate. So we would evaluate on left, because it does accept a math expression, and evaluate on right. I know it doesn't make sense, but it actually works, because evaluate takes a math expression and it returns a integer, which is something we can actually do math on. So that makes sense that I would call this function on the math expression that comes in. Okay? And why didn't I do that up here with value? Well, because there's nothing to evaluate with value. It's just a number. If you notice up here, it's already an integer when it comes in. So there's no need to do anything to it because it already exists as the type it needs to be. Okay? So I'm just going to, oopsie, copy and paste all these ones in here. So let's see, right, paste that in there, paste that in there, paste that in there. I should get rid of all their messages. Sure enough, it does. Yay! Okay. So let's see how this works. Okay, so I'm actually going to evaluate this expression. Let's do 25 divided by 25 divided by 5 minus 2. Let's see what that turns out to be. So okay. So let's create some constants here. I'm going to let 25 equal math expression number, because it is a number, equal 25. And we'll let 5 equal math expression number 5. I'm going to let, actually I'm not going to do that. I'm actually going to do times, and I'm going to subtract it by 20. We're going to let the product equal, we're going to have it equal, well, we're going to do math expression, so we're going to do multiply. We're going to take, what, 25 and 5, and it's going to do its math. Well, not yet. See here, there's the enum expression. You can have it view. Okay. Yeah, saying that it's math expression. Okay. Anyways, you get what I'm saying. Okay, we'll close that out. And now we want the sum, which is going to be this expression here, 25 times 5 minus 10. So this is going to be one expression, this is going to be the other one, which is just a number, right? So I'm going to sum mathematical expression subtracts. I'm going to do product, right? I did left and right, so I should have flip-flopped that around. Alright. Sorry, flip-flopped it around. I don't know what I was thinking. Let's keep it consistent, right? Okay. So product will be evaluated on the left side, and minus 20 will be on the right side. As you see 20, we haven't accounted for that, so we're actually going to do a math expression inside of here with number, and then we'll bring in 25. Okay. Now, okay, we see sum hasn't added or subtracted anything, right? So how do we do that? Well, we'll get there. We'll just do a print, and we're going to call our evaluate function. We're going to call in our expression, which is sum. That's what we want, right? You see it equals 100. Is that right? We'll see. 25 times 5. I think so. I have to do the math. I believe it is correct. 25 times 5 is 100 minus 20. Oh, yeah, it is correct. I put 25 here instead of 20. Now it should be 105. Okay, that's correct. Yes. All right. Okay, so that is recursive enumerations. Fun stuff. I definitely recommend, if this wasn't enough for you, to experiment and explore how to do this. A thing I would probably suggest doing, which I think I'm going to do on my own, is I want to have this function inside of this enum. I want to see how that works. How about, that's a good idea. I'm pretty sure you can do it. I'm pretty sure I can do it. Okay, fun times. So I've covered quite a bit in this set of videos. First off, enum syntax, type inference, matching enum values using switch, very important. Associated values, work through that. A little talk about methods, which is basically a function and where it occurs, whether it's an enum structure or class. Raw values, implicitly assign raw values. Explicit, initializing a raw value. Recursive enumerations. So yeah, I covered quite a bit. I do plan on doing another video that kind of gives some examples. Like I said, enums, I went over this over and over again, trying to cement it into my brain, and I did a really fun example involving rock, paper, scissors, lizard, Spock. Don't know if you know what that is, but I'm a huge Big Bang Theory fan. So if you want to see how I implement this in an enum, it's kind of funny. I like it. I'm sure there's easier ways to do it, but I just really wanted to practice a little bit with enums and having fun with them. So if you want to pop over to that video and see how I do it, awesome. If you found this video and these sets of videos really helpful, again, please like if it's really helped you out. And if you really like all my videos, please subscribe. Again, thank you. Till next time.